Hi again, my name is Sheila Ramjug and I'm the current Early Career Member Representative of the ERS Monograph Editorial Board. Now, as many of you know, I'm currently a consultant pulmonologist working in the Manchester region of the UK, and I'm super excited to be recording today's podcast as this edition of the Monograph is dedicated to eosinophilic lung diseases. As a clinician, we frequently see patients with common and rare lung conditions and raised eosinophils, and this monograph helpfully provides us with a step-by-step guide as to how to approach such a patient, as well as actually updating us about the eosinophil itself. We are fortunate today to be joined by both guest editors, David Jackson and Michael Wechsler. David is an Associate Professor of Respiratory Medicine at King's College London and Clinical Director of the Severe Asthma and EGPA Centre at Guy's and St Thomas's. Michael is a Professor of Respiratory Medicine at the National Jewish Health in Denver, and his work focuses on translational asthma with an emphasis on clinical trials, novel therapies, and management of EGPA. First of all, I was just curious, David, how you're getting on in Portugal and what you're doing in Portugal.
Yes, so I'm very happy to be speaking to you from the ERS Lung Science Conference in Estoril. This obviously is the first time there's been a meeting here since the pandemic started. And for most of us here, it's the first time we've had a face-to-face meeting for almost 3 years. So it's wonderful being here. This is actually my first time to the ERS Lung Science meeting. It's fantastic, really, really interesting. Obviously, as the name suggests, much more scientific than the usual ERS Congress, but fascinating to see everyone's new research. A lot of the data being shown here is unpublished. So it's brilliant, really, really fascinating. A great meeting to come to in the future.
And poor Michael's been abandoned then, is that right, Michael?
Yeah, sadly, I am doing well in Colorado. It's a beautiful day with snow covering the streets, but I'm heading off to California in about an hour, so it'll be warmer and nicer there.
I was curious, Michael, why the interest in eosinophilic lung disease? How did you get into it?
Yeah, so my interest in eosinophils actually just happened by chance. Actually, when I was in medical school, we had a very smart guy in my class who every week would read the New England Journal of Medicine and the case reports. And he would always quiz us and say, okay, a person presented with this and that. What's the answer? We were in medical school. We had no idea what he was talking about. One week he said, well, a woman presented with asthma, eosinophilia, pulmonary infiltrates. What is it? We had no idea. He said, well, it's Churg-Strauss syndrome. Remember that. I said, okay. So I filed that away in my brain. I went through the rest of medical school, didn't see a case. I did all of my training and residency, internship, residency, didn't see a case. And then halfway through my respiratory fellowship, I got called by one of the residents on the ward who said, we've got a patient for you. She's got asthma, pulmonary infiltrates, neuropathy, and a rash. We want you to do a bronchoscopy. I said, no need for a bronchoscopy. It's Churg-Strauss syndrome. So that was my introduction to eosinophilia and eosinophilic lung diseases. And we decided to write up that interesting case report. And all of a sudden, people started referring patients to me with eosinophilic lung diseases. And before I knew it, almost half of the patients that I was seeing were patients with eosinophilia. And that was before we had any good therapies. Now, we're 25 years later, and it's really exciting because we now have new therapies, new approaches, and new ideas about what eosinophils do and how they work.
That's a fantastic story. And I actually genuinely can't believe that was 25 years ago, Michael, from looking at you. And David, what was your route to your current position? And any mentors along the way as well?
Yeah, so it was interesting because, again, when I was a junior doctor, I would see patients on the ward with acute asthma exacerbations. And the only thing that really stood out when you looked at their blood counts was the eosinophil count. Everything else was usually in black, and then the eosinophil count was in red. It was a thing that was consistently elevated. And that really sort of got my interest in it. And it was clear that, unlike most respiratory conditions, asthma was, with the eosinophil count, it was the one condition where you actually had this biomarker. And although it's been, it feels like it's only a recent finding that the eosinophil is a biomarker. Actually, we've known about it for a long, long time. Going back, Barry Horn's paper in 1975 in the New England, he clearly wrote that the eosinophil count can be used really in three ways. Firstly, for identifying asthma activity, so really symptoms and control. The second, it could be used to make a decision about steroids, increasing or reducing. And the third, that it gave you an indicator about the risk of an exacerbation. So for me, it was fascinating that there was this relationship. And at that time, it was really unclear what the true significance was. And I guess through asthma, then we started sort of seeing these patients with EGPA Shurg-Strauss, like the one Mike described. And the one thing, again, that was coming up here was they had terrible asthma and the eosinophil count was really high. And that's kind of how it started. And then, I went through respiratory training. I did a job at the Brompton in the asthma unit there for 6 months. And then I worked my PhD in asthma with Seb Johnston at Imperial. And when we infected patients with rhinovirus, again, the one thing that really came up was this T2 phenotype, and the eosinophil count went up in the bowel when we infected patients with rhinovirus. So there was something, really clear, a really clear signal in terms of the eosinophil in asthma and exacerbations and related conditions.
Thank you. And I suppose that leads us in a way to, why do you both think this edition of the monograph is so important, particularly given that Michael's been doing this for 25 years and has just mentioned how things have changed so much? So why should we all be reading this edition?
I think one of the key things is that our understanding of eosinophils and what they do has really evolved so much. And like I said before, we now have new therapies, whereas just 5 to 7 years ago, we didn't have any appropriate targeted treatment approaches for patients with eosinophilic lung diseases. We gave people corticosteroids. Patients developed side effects of the corticosteroids, cataracts, glaucoma, osteoporosis. Now, in the last 5 to 7 years, we've developed these new therapies, and it's really given us the ability to both treat our patients, but also to get a better understanding of the eosinophils, that there are different types of eosinophils, that there are different states of activation, that the eosinophils can cause not just asthma, but also underlying tissue damage. So the fact that we now have a better understanding, and we don't have a perfect understanding yet, but the fact that we have a better understanding really helps guide us, and really was the major motivator that we need to get all this new information in one compendium, in one place, so that physicians who are interested in eosinophilic lung diseases could do a one-stop shop for a better understanding of this important cell and all the diseases associated with it.
I have to say that the monograph is written beautifully. I found it, as someone who isn't specializing in eosinophilic lung disease, I found it incredibly helpful. Personally, I wish I had this book when I was a registrar, but I had Rob Niven, who educated me massively. And do you think patients historically may have, given that there's a huge disease area as such, but different types of presentations, but do you think historically some patients maybe might not have been managed as well, or there were delays to diagnosis?
I think with asthma, it's still the case now where, although we appreciate the usefulness of the eosinophil count as a biomarker and how powerful it is as a biomarker, we still, in many cases, patients' symptoms rather than objective inflammation is being treated with the assumption that all those symptoms are due to inflammation. And so, you can have a patient with asthma who is very obese. You can have a patient with asthma who also has cardiac issues or another problem, and they will naturally be very symptomatic if they walk up 2 flights of stairs. But those symptoms aren't due to areas of inflammation. And the beauty about the eosinophil count, and it's the same for pheno, is it gives you a direct window into the likelihood that those symptoms actually are being driven by inflammation. And I think what definitely happened in the past, and still happens, although less now, is that there was the assumption that all those symptoms were due to inflammation, and steroid was the knee-jerk response. Systemic steroids, and as Mike alluded to, with significant consequences in many cases. And I'm convinced many patients over the years have actually died of the adverse effects of systemic steroids rather than their asthma. And so now it's so important going forward. And it's not just asthma, I think it's going to be increasingly across other conditions, COPD as well, where we've really got to pay attention to the eosinophil count. In the same way as, you would never dream of starting an antihypertensive on a patient before measuring their blood pressure. And it's exactly the same way. If you're going to treat inflammation, at least measure the level of inflammation before starting to put somebody on systemic steroids and so on.
One of the chapters I personally enjoyed was the safety of eosinophil depletion. And I had actually never thought of that. I had never thought about the consequences. Explain a little to the listeners about this chapter. What does this explore?
So I was very lucky to write this chapter with Ariel Munitz from Tel Aviv in Israel, who is really a world expert in eosinophil science, really. And what's interesting is, well, clearly we have this cell. We've evolved to have this cell, so it's not unreasonable to assume that it must have a role. But we now have these therapies, and I'm going to use benralizumab as the example because it's the one that really knocks out your eosinophils almost completely. Mepolizumab and mepolizumab reduce your eosinophils, but you still have some. So the benralizumab sort of creates what is essentially an eosinophil deplete human. And interestingly, now we've been using these therapies, since the original studies, for over a decade in asthma and COPD in related sort of hypereosinophilic conditions. And as yet, there doesn't actually appear to be any signal of harm. When you compare it to placebo, there's no increased risk of infections, viruses or bacterial infections. The phase 3 studies for benralizumab in asthma recruited patients from Asia and South America and South Africa, where there are helminth infections, and there hasn't even been a single case report. So it's very interesting that actually it would appear that you can get rid of someone's eosinophils and there isn't any significant consequences. But I do think that there will be some patients, we just haven't seen them yet, where actually there is not the redundancy in the immune system that there is across the board. And for them, it's maybe there'll be some consequences, but I think there's going to be few and far between. Not dissimilar from the idea that with COVID vaccines, for example, they're incredibly safe at 99.9%, but there is the one or two who have this weird snip in this or that, and actually they have a bit of a problem with it.
Michael, as well, you mentioned too about different types of eosinophils or different ways that they might be working. Would you like to explain a little more about that?
Yeah, I think we've long recognized that the eosinophils play some type of homeostatic role, and they play a role in modulation of adaptive immunity. They have effects on nerve cells. They have all sorts of effects in all sorts of different organs. And one would think with such an important cell that has so many potential effects that by depleting eosinophils, you might have some deleterious effects. Fortunately, with the therapies that we've seen, there aren't significant deleterious effects. However, one of the things that we've observed is a better understanding of asthma as a whole. Several studies previously have shown that there are different types of eosinophils, there are different states of activation, and by depleting eosinophils, you may not necessarily have deleterious effects. But one of the things we've learned is that there is more to asthma, there's more to these eosinophilic lung diseases like EGPA than just the eosinophil. We've gained so much of an understanding that we would have thought, okay, we're going to deplete the eosinophil and everything is going to be cured. And I remember participating in one of my first head-to-head debates about 20 years ago now at the European allergy meetings, eosinophil friend or foe kind of debate. And back then, we thought that the eosinophil was the be-all, end-all, and it was before we had these new therapies. What we've come to understand and learn about these diseases is that there is a lot of redundancy, there are multiple pathways, and that these diseases are very heterogeneous. So, for instance, in asthma, in patients with eosinophilic asthma, there was initially this thought that eosinophils were responsible for nitric oxide production, which we measure in many of our patients, and that by depleting eosinophils, we would then no longer see a nitric oxide signal. But that hasn't been the case. And as we've given these therapies to patients, we've recognized that the nitric oxide that we see is made by other sources. In fact, it's made by IL-13, that it's an IL-13 product. So by depleting eosinophils, we've gained a better understanding of the pathophysiology of each of these diseases, whether it's patients with EGPA who continue to exacerbate and may have more of a neutrophilic inflammatory pattern, or whether it's the nitric oxide that continues to be produced in patients with eosinophilic asthma. So what I've learned is that there is so much that we don't understand, that there's so much more that we need to learn about eosinophils and about the pathophysiology of these diseases.
Bearing that in mind, what do you both see as the future? What are the future questions? You've alluded to some just there, Michael. Are there areas specifically that you would like to hone in on?
Well, I think we still need to get a better understanding of what the role of eosinophils is in, for instance, parasitic infection or helminthic infection. Why do eosinophil levels go up? Are they protective? Are they just a sign of inflammation? Or are they irrelevant? And I think those are the kinds of things that we're trying to understand. What about in tumors? There are many cancers that result in an increase in eosinophils. Is that a side effect of the tumor itself? Are the tumor cells producing eosinophils? Or are they just innocent bystanders and a type 2 inflammation that's going on in the context of those malignancies? So I think expanding beyond the eosinophilic lung diseases, trying to understand what's going on in diseases like eosinophilic GI disease and these infectious processes, and also what's the role just in general metabolism of the eosinophil? What are they doing in us? And I think those are some of the future directions that I think we need to get a better grasp on.
And David, are there any specific areas for yourself that Michael hasn't touched on?
We have a perfect opportunity now to really understand the role of the eosinophil in these conditions. So let's just take 4 conditions which each start with eosinophil. So we have got eosinophilic asthma, eosinophilic COPD, EGPA, the first word being eosinophilic, and eosinophilic pneumonia. Now the assumption is, because they all start with the word eosinophil, that the eosinophil is the key dominant cell. But we actually now know that whilst that is the case in many of those patients, when we deplete eosinophils, there is a group of patients that remain symptomatic, continue to exacerbate. And so actually, for the first time, we are now in a position where we can truly delineate what these phenotypes are and the extent of them. And I think what these drugs are now going to allow us to do is actually to redefine the phenotypes of these conditions and to say within eosinophilic pneumonia or EGPA or eosinophilic asthma, there's this phenotype where the eosinophil is absolutely dominant. You take away the eosinophil with a drug like benralizumab or mepolizumab, you reduce it, and the patient feels like they no longer have that condition. And then you have other patients where you have removed the eosinophil, but they continue to struggle. And so we're now going to be able to do that. And I think that's what's so exciting about the next few years. We can really start to properly understand the heterogeneity of these conditions and what other pathways are important in those other patients.
And I think that, there's been so much evolution in science and in our appreciation of genomics and transcriptomics and proteomics and metabolomics. All of those omics we can now apply to the fields of eosinophilia, all the different diseases, to get a better understanding of what is the underlying biology. And maybe we need to move away from some of the canonical terms and maybe focus in on the underlying pathophysiology of the diseases, so that maybe we shouldn't be calling these diseases eosinophilic asthma or eosinophilic COPD, but maybe we need to think more about the underlying pathophysiology of what's going on.
It's obvious from the passion that you two have, that's evident throughout the monograph, genuinely. And if you two had to pick 1 or 2 chapters that were must reads, which ones would you pick?
Look, I think it depends on who the reader is, but I think, assuming they're not sort of eosinophil nerds like Mike and myself, I think one of the key chapters will be the chapter that Brian Kent led on, which is the differential diagnosis of pulmonary eosinophilia. I think that's a really, really important chapter. And I say that because I will often see a patient who is referred that actually the assumption was it was just bad asthma. But when you look back, you can find eosinophil counts of 4, 5, 6, and they had EGPA. And unfortunately, these conditions are often missed. And so a better understanding and an approach to how to investigate these patients, I think, is really, really useful and important. So that's one I would go with first.
I actually agree with David that the differential diagnosis is so important, and it forms the basis of our understanding of many different diseases. But if I had to pick another chapter, I'd probably go with the future prospects of translational and clinical eosinophil research. Again, I feel we're just at the forefront of our understanding of eosinophilia, And, we're trying to understand whether eosinophils are culprits or whether they are playing a role in homeostasis or whether they're innocent bystanders. It's clear from this monograph throughout that the eosinophil is key for all these disease entities. But I think there's so much evolving. The science is evolving so much. And I think that chapter really ties together what we currently know and where we're going in terms of our understanding of eosinophils, and really provides a scaffold upon which we can build our understanding and hopefully learn more about all of these diseases. What are the roles of eosinophils? What's so special about activation of eosinophils? How are eosinophils playing a role as effector cells? And also, maybe it'll give us insight into new therapies, because the therapies that we have, the new therapies that we have just in the last few years are outstanding, but maybe they're not doing everything that they can do for our patients. So maybe this chapter can be a source of getting ideas about how to approach these diseases in a different way.
Thank you, Michael. And I was just curious, when you were writing or guest editing this edition of the monograph as well, who is it aimed at?
I think this monograph is aimed at a wide variety of different individuals who may have interest in eosinophilic diseases and eosinophilic lung diseases in particular. I think that it's a compendium that a junior physician, a junior scientist can go to appreciate the breadth of eosinophilic lung diseases, what we know and what we don't know, and where we're going. But it's also useful for more senior physicians, more senior investigators, to give them ideas about how to approach things in the future. And it may even be useful for patients and family members who want to know a bit more about what's ailing them and why the eosinophil is important. So I think that it can be useful for all of those groups, and also maybe even for pharmaceutical companies who are developing therapies for these important entities, so that they can appreciate that it isn't just eosinophilic asthma, it isn't just EGPA, but there are many other disease entities that could be involved and implicated by eosinophil activity. Right now, we're at a very exciting time, and we have these new therapies, we have a better understanding of the diseases, but I feel that there's so much more that we need to learn. And I'm hopeful that by utilizing this monograph, it'll be a jumping point for learning more to try to get, whether there's any other new paradigms that can be identified in appreciation of these diseases and what roles eosinophils play.
And I'll just add that this is a very fast-moving field. It's literally in its infancy in terms of our understanding in reality, because we were waiting for these therapies to come along in the same way as, from a basic science point of view, we use mouse knockouts. Now we can do that with humans and humans with these conditions. So I'm looking forward to edition number 2 in a few years' time and the update, and looking back at, what steps we've made, because I think the next few years are going to be incredibly exciting in this field.
Again, I would like to thank our guest editors for their evident passion and dedication for producing such a timely and thought-provoking edition of the monograph. I would encourage not only established clinicians and scientists in the field to read this edition, but also trainees, as I wish I'd had such a compendium when I was training. But then again, I was fortunate enough to have Dr. Rob Niven to hand. We hope you enjoy reading and listening. Take care.